So the first one is giving us measurements made for different diameters and resistance values. So we're looking for what graph to plot on the y-axis and on the x-axis. Remember, to get a straight line, that means the slope should be a constant, which means we're looking for a variable on the vertical and a variable on the horizontal to be directly proportional. So we're measuring resistance and diameter. Now, if you remember the resistance relationship, which would be this, the resistivity times length divided by the cross-sectional area, since it's inversely proportional to radius squared, it will also be proportional to, this is what we're looking for, 1 over the diameter squared. This means you can plot that versus that and get a straight line. Since it's not one of our options, we could easily flip the two and plot d squared versus 1 over r, and that will still give me a constant slope. So in question 2, we have an electric heater and we're given power as 1000 watts when the voltage is 200 volts. Now for this, I'm using V square over R version for power because I'm relating power and voltage, and when the length is changing, the resistance is changing. So I write an expression for the first case. 1000 is 200 squared over length L, which would be resistance R. When you increase the length to 2L, this is going to be 2R. So we were going to be multiplying the R by 2, basically dividing the whole thing by 2, which is going to be 500 watts. So our answer is B. In question number 3, we have two resistors made of uniform cylinders of the same materials. So that means the same row. It won't affect our answers. And they're connected in series. Now they have equal length, but the diameter of Y is twice the diameter of X. So if this is diameter D, this is diameter 2D. We are given that resistance of Y is R. Now in question 1, we figured that R is inversely proportional to the diameter squared. Since the diameter of Y is twice, its resistance is going to be 4 times smaller than X, which means if Y has resistance R, L has resistance 4R. See, its diameter is half, so resistance will be 4 times bigger. Well, since they're in series, the total resistance will be the sum, so our answer will be 5R. Okay, in question 4, we are splitting a wire of length L into 2. Its radius is R initially, and its resistance, let's write an expression for its resistance, which would look like that. So that's our R. By keeping the same total volume, we split into 2 and stretch to 2L. So what happens to the volume is initial volume was pi r squared L. Half of the volume, because we're taking half of it, is going to be pi r squared 2L, now that we are stretched into 2, which is going to be nu r, this nu r, let's just give it a different color. This is our nu r, half the volume of 2L length. The nu r is going to be r over 2 if you do the math. So by multiplying by 2L, you are multiplying r by 2, and by reducing radius to half, you're multiplying it by another factor of 4. So basically, each half will now have a resistance of 8R. Since we're connecting the two pieces of 8R in parallel, their combination will have a resistance of 4R. Now we want to find the resistance of W2 over W1. So since they're made of the same material, they're both copper, I'm going to ignore the row. We know this is double L. Now because the length is doubled, W2 is automatically going to be twice the resistance. And since the diameter is half, this is going to multiply the resistance by another factor of 4. So if this is 1R, this is going to be R times 2 because of the double length, times 4 because of the half diameter. So it's going to be 8R value. Since we're looking for the ratio of W2 to W1, it will be 8. Okay, question number 6. We have a copper wire of length L. Let's write an expression for the R that is given in our situation. So let's put that in here. The radius of a copper wire with length L over 2. Let's write an expression for our second wire. The new wire will also have R, made of the same material, but it has a length L over 2, so let's put a 2 in the denominator, and we should have a pi here. What is the radius? We're looking for the new radius. Now, to relate this into that, let's get rid of the common stuff. And since this is also equal to R, I can set these equal to each other. 1 over R squared is equal to 1 over 2 nu R squared. Let's say that is nu R. R squared over 2 is the nu R. So let's take a square root. We end up with that. So our answer is C. We have again 2 wires. Let's write an expression for resistance of X, which will be pi R squared. A wire of Y made of 4L, same material, and again its resistance is 1R, and we don't know its radius. Since these are equal, let's cancel the common things, and 1 over R squared, 4 over R squared is going to be 1 over R squared. When you rearrange this, you will get this red R. Well, you can cross multiply and take the square root, and you will see that 2R is going to satisfy. Now, number 9, we have X and Y. So simple ratio. This has a length 2L and 1L. And X also has twice the cross-sectional area. So this is 2A and A. Well, resistance of X, resistance is proportional to length over area. Well, more specifically with the row. But if you see that this ratio is the same as that ratio, these resistances are equal, so their ratio will be 1. And the last question, we are looking for the new resistance in terms of R. So once again, let's write an expression for the first case, L over pi R squared. I'm going to use D as R because I want to avoid the factor of dividing by 2. It will cancel anyway. So the new conductor will have twice resistivity, twice of L, and the diameter 2D, which is going to be, when you square it, 4R squared. Square of 2R, so 4R squared. you will see that these cancel. So if this is 1R, that's also 1R. So our answer is B.